I will turn it over to you.
Perfect.
Let me go ahead and promote you to the meeting host. There we go. All right, there you go.
Right. So thank you, Ashley, and great to be here. And especially great to be talking about kind of a topic that is so near and dear to my heart, which is not just OTel, but how can we use OTel in practice? So like for me, technologies are interesting and all of that, but it is when they actually can change our day-to-day and improve our code or allow us to do something that we couldn't before, that they become not just kind of an anecdote, but something that's interesting. So just about me, most of my career has been as a developer for over 20 years now. Really switching between many different languages, from Python to Java to .NET to Node. I think I had the opportunity to dabble with most languages by now. And at the same time, my own personal tragedy as a developer is that I never kind of managed to pick sides between product and dev. So I had the opportunity to kind of do a lot of dev-oriented positions, and then find out that I couldn't really not care about the use case and the user and why are we doing this and the design. And then I became a product manager only to find out that I really miss coding. So I ended up with a lot of different kind of in-between positions until I found my spot. But throughout, I've been very interested in general about the development process and how can we make it more effective. And I think this is like a good way to explain that would be through a story that is kind of very emblematic of what I've seen across me in different teams I worked at. So I'm going to tell you a very common story for a developer. We're going to call him Bill in the context of this specific tale. And Bill's task is something we all do every day, which is develop a piece of code and then get it into production. And, 20 years ago, Bill's job was very, very easy. And I used to do that all the time because all we did was we developed the code, then we wrapped it up real nice. We handed it over to the guys across the hall called the QA guys, and they would take it from there. And we would never hear about that code again unless something broke, and then we had to support it. But that was where the role of the developer ended. And of course, this is no longer the case. So, today, developers do everything from writing tests, sometimes even taking care of deployment. Many developers I know are very well versed with Helm files and Terraform, and they kind of maintain an accountability and responsibility that is end-to-end. And this is, the shift right, shift left, whatever way you want to call it, but it's a trend that's been happening across the industry. And I've been following that, and my team, like other teams, was asked to kind of accelerate and make it more of a continuous deployment cycle and accelerate releases and all of that. And Bill, my hypothetical developer, is doing all of these amazing things. So he's writing tests, he knows all about the deployment, he knows how to define what the service needs and how to get it working end to end. The question is, what happens then? So the day after, the minute after, the second after Bill deployed into production, what happens then? And this is something that bothered me, because what I expected Bill, the hypothetical developer, to do was to ask questions. Did the code actually work? Was it even executed? I've seen more than one, I was witness to more than one occasion where meticulously written, beautiful code was just one bad if statement away from actually getting called in production. And nobody was looking for it, right? Is anybody using it? Did it change life for the better or for the worse? Did it actually improve things? I would have a developer rewrite the data access layer or some queries and then push it into production and move on to the next feature. And this is something that I saw repeated. So 99% of the times, after kind of doing all of that hard work coding, after doing all of that hard work testing and deploying, everybody would forget about it and move on to the next task. And this bothered me. It bothered me because there is this amazing discrepancy between what the developer knew about his code and the amount of data that is there. And I looked to the kind of basics, you can say, the DevOps loops that, by now is completely overquoted and misused, but still it's kind of just a nice way to visualize the process. And I noticed something very weird about it. And it took me a while to spot it, but I could kind of not see it and not unsee it after I kind of noticed it for the first time. So let me ask you guys, does anybody notice something a bit off about this diagram? And this is just one of many. I kind of found it online. There are many diagrams that look like this, and I think most of them have the same problem. Does anybody notice anything weird or peculiar here? So the details kind of mask it, and I didn't notice it at first, but you would notice that there is kind of different segments of the DevOps process, from planning to building to continuous integrations, and each of them have lots of different tools and ecosystem tools associated with them. Except for one thing, one segment at the middle of the diagram that says continuous feedback. It actually seems to completely describe what I'm talking about, which is how do we take that really useful data from, I don't know, testing, production, and back into me as a developer, into my code. And there is no tool there except for Salesforce, so that I, after giving this talk so many times, I still haven't figured out why Salesforce is there. But there is no tool for continuous feedback, which is something that to me was amazing. Like, if we don't have continuous feedback, so all we're doing in accelerating releases is really just throwing code over the cliff at a higher velocity, because we're not getting any information back, and Bill doesn't know whether he improved things or not, because it's very hard to find that out. So then I thought to myself, well, if only there was a way to get instant access to objective data about the code always. And this is kind of how I got to OpenTelemetry. So for those of you who are not familiar with OpenTelemetry, OpenTelemetry is a specification, and there's an implementation in many languages for observability, for tracing logs and metrics. And there is absolutely nothing that I found that's extremely smart or revolutionary about OpenTelemetry, except that everybody agrees on it. And I think that's the main thing, because while it's more an evolution than a revolution, it is A, stable, and B, something that's being picked up by many tools and platforms, because suddenly it's, you don't need to pick between different proprietary standards and technologies. There is this one tool that is also open, that everybody can have access to, and that has the effect of A, making coverage amazing. So like, if I'm writing if I'm the platform maintainer for, I don't know, Flask or Hsv.py or Django, or the adapter for Kafka or whatnot, I don't need to think about, I'm going to support this protocol or the other for observability. OTel is just a very easy thing to add on top. So it means that there is overwhelming coverage, and it also means that a lot of ecosystem tools are starting to build up on top of it because it's an open source technology. It's an open source specification. So to show an example of that, and we'll go into code in a sec, I'm like the personal thing that I hate the most in all of the code examples that I go into is that they're very simplistic CRUD apps that just do update, delete, retrieve, and so on, because it's kind of not how real applications work usually. So I just created a sample applications as I was to illustrate it, as I was watching the Harry Potter movies at the time with my kids. I decided to just create an API for the Gringotts vaults, which, like, why not? And do all sorts of domain logic around converting between different currencies, or doing valuations of the different vaults. And I tried to create something that has several components to it, or microservices. So I have a fast API service. I have RabbitMQ to kind of do the queuing of the background tasks. A worker service, they're using Postgres, an external API that I created. And I did that with adding absolutely no observability built in, because I was trying to look at a scenario where you have an application and you never thought about OTel as something that you would ever do. Before I continue, let's get, there's a show of hands here, right? People can raise their hand. So raise your hand if you're familiar with observability and tracing specifically in the Zoom. I think somebody mentioned he was using open tracing, right?
Yeah, I did a yes.
Okay. Oh, and then Pat, I see. Okay, awesome. So just so a quick recap for those of you who are not familiar with what tracing is. So tracing is basically a way to look at a specific flow that goes through my system and kind of understand how it works. So in this case, this is the application architecture, and a trace could move between, because it's distributed tracing, it goes between different microservices. And it shows me exactly kind of the life cycle, or the kind of anatomy of what a specific request looks like. And it records that data for every request, so that I know that if the user used a specific API, it went through the fast API service, it did a couple of things, then it went to the RabbitMQ, submitted the message, then I know when that message was picked up, what was done with it, and so on. So kind of having end-to-end visibility about what goes on behind the scenes when somebody triggers an API operation. And then the other thing, or the other term to know, is a span. And a span is just a part of a trace. So for example, after getting the request in fast API, and before going into RabbitMQ to execute, I might have different segments or logical segments that I can specify that are kind of like a scope that I want to keep track of. So sometimes, like, you would use logs for that, which is maybe less powerful because logs don't have the context of who called them and what, and kind of the beginning and end part of it. But spans are very good at saying, okay, this is a scope of checking permissions. It has a start and an end, and I can start tracking who uses it and how much time it takes and so on. So it makes the job of getting to understand what goes on when somebody calls my code, especially when my code is using other people's code, and I might not have visibility into every process or understand exactly what went wrong. It makes that much, much easier. So just by enabling auto instrumentation, which is basically the very common way to enable OpenTelemetry in Python projects, it requires just installing a package and then running your application with that package. I can start benefiting from what I discussed before, which is that all of these packages and libraries already support OpenTelemetry. because it is such an agreed upon spec, because people already added instrumentation for it. So with a single line, I turned this one application that was completely opaque in terms of, okay, I need to start adding logs or something to understand exactly what's going on there, to the point where I have almost too much data, right? So now Hsv.py is telling me whenever it was receiving a REST request, and Pika, which is the library I used for RabbitMQ, is telling me whenever a message got enqueued, and it connects the dots. So it tells me, okay, I first received a request, then the message got sent. Then I have the Postgres package I was using, both of them, by the way, because I was using two different packages and two different services, telling me what queries were actually run and how they performed. And my HTTP instrumentation was telling me how the external API was being used. So I was able to transform from an application where I didn't have a lot of visibility at all about what was going on behind the scenes to really being able to drill in at any specific time and understand exactly what my code is doing. And understanding that promise made me think that the potential here is much more than I thought before. So if before I had in mind build a developer developing his code, then needing to check how that code fared in the real world, since the whole kind of development process is more of a loop, that information, or the information about how the code that exists already runs in production, is something that was available to Bill all of that time, even before he got started. So you could think about a flow where a developer could start by saying, well, I want to change this code segment. Who is using it? Is it even used? Are there any issues I should know about? What should I optimize for? Is this the place in the code where there's high concurrency and it's kind of a bottleneck, and every millisecond added here will propagate through the entire system and affect everyone? Or is this a very forgotten place in the code that, you know, maybe gets called once a month and I shouldn't worry about it? Or maybe it's not even hit at all and it's kind of dead code that I need to remove. So there are a lot of questions that I can think about throughout the GitOps process that this information could be really valuable for. And this is, again, where the discrepancy between just how much amazing data applications collect today versus this, you know, a ridiculous small percent of the data we actually use in the day-to-day, that made me think that, you know, that there is a big potential here to connect the dots. And let's kind of take a look at how that data currently looks like, just using open source tooling, and APMs offer something very similar. So in this case, I'm going to showcase this specific example, and I'll send a link to the repo. And this is using I'm just using VS Code here, and this is that same Hsv.py application. And I'm just going to run it. If it's not already running. Okay. And then let's browse my Gringotts API. There it is. And let's do something like maybe log in. And following that, let's maybe do an appraisal of a specific vault. Perfect. Now, again, normally I just did those actions, and as a developer, this is the code that I'm looking at, and there is no link, right? I don't know what just happened, like whether somebody was using my code at all, whether it's being used in testing, whether I just ran it for debugging. There is no information about what actually occurred. It's funny, we have so much data at debug time, but so little data at runtime. So one tool that allows me to visualize the traces is called Jaeger. It's an open source tool, and it's extremely ridiculously easy to get it started. Let me select this specific service and see what data we have. And here we kind of see the different actions we took. So for example, this is the login, and we can see exactly the different stages that happen. And again, a lot of these come automatically just because I enable instrumentation. So I know what our request looks like. So I see that this is the HTTP request, and then there are some logical segments like authenticating the vault owner and key. And there is a retrieval operation, and I can actually see all the way to the actual SQL statement that was executed and how much time it took. So there is a lot of data here, and I can really understand from here what exactly is going on. And this is revolutionary, right? We didn't have this before. It's amazing to be able to get all of that data and be able to access it very easily. And it really replaces a lot of technologies that are more proprietary and kind of require me to look at a specific vendor and be dependent on what features they decide to develop. And suddenly it becomes very easy to enable OTel. It's kind of like another runtime config almost, and I have all of that data available. But I will, and I don't know if it will surprise you, but I will tell you that once I've implemented OpenTelemetry, I actually checked with the developer, with Bill again, and asked him, are you actually using this? Are you, I just showed him the same nice demo that I showed you, the way that he can get into the application traces at any time and explore exactly what's going on there. And what do you think his response was? Anyone?
Hopefully it was a yes.
So no, it was, this is really cool. I like it, but he never used it. And there's a reason for that. It took me a while to figure out what that reason is, but there is a very good reason for that. Now, it kind of reminds me, and this whole kind of how observability fits into development really reminds me of the whole transition we went through with testing. Because it used to be that with testing as well, it wasn't something that, worked when we asked people to do it out of the kindness of their hearts and their own spare time. It just didn't work that way because there was always something more important. There was always something urgent. It was, frankly, a context switch. It can generate work that's very tedious that you don't really want to do if it finds problems. So leaving it up to developers to select when they run tests made no sense, which is why we evolved to continuous integration. So it kind of happens automatically. You don't think about it. You write your code, tests get run. If there is an issue, you know about it. And so the loop continues. And it's exactly the same thing that needs to happen with observability in order to incorporate it really into the dev process. So we need to be able to know all of those important things about the code automatically without thinking about it. The other thing is that it still requires a lot of expertise because what we were looking at right is what we were looking at right now is a very kind of interesting anatomy of a request, of a specific single request. But think about production environments, testing environment, where there's lots of requests streaming in all the time. It kind of becomes a needle in a haystack to analyze it correctly. It's doable. You do need some knowledge of statistics to remove outliers, to understand trends, to kind of start making it into something more useful and actionable. And this is exactly where kind of my specific involvement with continuous feedback, as I call it, and OpenTelemetry began. So I started thinking about, okay, what are the ways that we can actually overcome these hurdles because they were frustrating me as a developer? How can we, on the one hand, make it continuous, make it so that a part of the process will always be collecting all of that data and making that available to me and known to me? Before I start working on the code, as I code, after I check it in, all of these stages need to be addressed. And then lastly, how do we kind of bake that expertise into whatever tool it is so that I don't need to know kind of to do a refresher on statistics 101. It becomes something that I get out of the platform. And to do that, I created a project called Digma AI. And I want to show you what I've done, not so much so that you may use it yourself, but also to kind of show you a vision of what I think coding is evolving towards by making developers own much more of the pipeline, including observability. So to illustrate that, I'm going to go back to this same code. Only imagine right now, actually don't imagine, it's happening. In the background, there is another tool called Digma, which is listening in to all of these things that I'm doing and analyzing them. So we have great generative AIs today that can create code on the fly. Digma is an AI that can evaluate code on the fly. So it can just look at these amazing sources of information, the traces, metrics, and all of the rest, and evaluate them, understand what they mean about my code. So let's just enable one of the outlets of that information, which is the IDE plugin. So I'm going to enable this in my environment and go back to the same code I was looking at before, which frankly, all I knew about it was that it's passing tests. And the minute I do that, things start appearing, as you can see. So we can see there is, and let me make it a bit bigger just to make sure everybody can see. So we can see that there is an n+1 suspected here. For those of you who are not familiar, it's kind of a query anti-pattern where you're doing too many selects because of bad modeling usually. We can see a bottleneck is relevant, is happening here, which means it's kind of a code that's slowing down everything else. There's low usage in terms of concurrency and a lot of information that is actually interesting to know. And beyond interesting, it's something that I can use because now I can count on that when I make changes or when I make corrections or when I'm testing. This could be the test of my own code. And if I click, I always see more information. So I can see that this specific information is coming from the CI. I can see that local data hasn't hit this at all. And each of these issues is actually an aggregation or something that is taking all of that raw data that you saw before and trying to make it into something specific. So in this case, for example, there is a specific n+1 issue that we looked at before, and we can go to that source and we can see exactly that the culprit is a specific query, and we can see it here. It's actually repeating 102 times per request, which is a lot. We can see who it's affecting. So in runtime, who's actually using this code, which is the authenticate and token operation in the Vault service. And all of that information is something that I don't need to think about. So it's not something that is now optional for me as a developer to kind of, am I going to run profiling? Am I going to look at the statistics? No, it just happens automatically. So it becomes something that is continuous, which is basically what we were going for. And if I do want to drill down a little bit more and understand exactly how that looks like, where is that issue, I can always go down to the next level of seeing the trace, only this time it's not something disconnected. It's coming from a specific example. And in this case, I am seeing that this query is repeating way too much as an example. And the same goes for errors and for security issues and for other things that are related to my code. And the analysis just becomes a continuous part of the development cycle, which is my personal take and vision and what I'm trying to kind of get people to talk about more, because a lot of these ideas come up just by having people see where it hits them and where it's the most valuable in their day-to-day, to go beyond kind of looking at these static pieces of code and understand how they run. And the goal is to make it as simple and obvious as find usages or autocomplete or all of these things that you know. And by the way, that example that I gave before about the if statement and the code not being executed, you can see it's actually happening here. There is somebody misplaced the return and this other code never gets called. So to sum up, I think that continuous feedback is a great application of OpenTelemetry, and something I hope, and there are other tools that are shaping up in the ecosystem that do exactly this. I was just showing something that I'm close to, but it's not, fortunately, not just me and not just the project that I'm working on. There are many observability companies that are trying to do the same thing, which is explore how we can benefit from all of that data and to kind of cross that gap between tons of data and developers who are writing code and not being aware of it. And I think for me, the best illustration about how important it is, and I'm going to share my screen once more, and what I'm going to do now is look at the same code, only this time I'm going to disable the continuous feedback layer on top of it and go back to that same code. And now all of that information that we saw before is still relevant. It's still happening, only I'm blind to it. So just to kind of get the impact of the fact that there's a difference between coding with your eyes closed, which is essentially what I'm doing now, because there are a lot of great things to know about this code. I'm just not seeing them, and actually making that continuous feedback connection in the DevOps loop happen. Thank you. And I'd be very happy to answer any questions.
We have a question from Hamilton. Hamilton asks, how do you decide how granular to implement spans across all of the modules?
That's a very great question, and I'll tell you my personal strategy. I start from the outside in, which means just by activating OTel, you'll get all of the edges instrumented. So you'll know your HTTP calls and database calls and query and queue calls and all of these things. And then after you look at it, you can see where you need more information. So for example, you have your domain logic, or you have like specific areas of the code, and you really want to track that. So like if you don't use tracing, you may add a log statement or save the performance to log. And tracing is very much the same thing, only it does all of these things for you in terms of understanding the context and who was calling me and how long it took and so on. So I would just add on demand where it makes sense. But just as in logging, where it's very easy to create performance problems by introducing logs too granularly, like if you have a code loop that gets invoked, like, I don't know, millions of times, and you add a log statement inside the loop, you're going to create an issue. And it's the same with tracing. I do not recommend tracing each and every function, but as you look at the data it provides, you'll see where the blind spots are, and this is where you'll want to judiciously add more tracing. So going from the outside in is kind of my strategy.
Do we have any other questions that anyone would like to ask?
I have a quick one. So this was really cool from like you said, tracing and flow analysis. Have you done anything with discrete events with OpenTelemetry? And if so, how does that workflow compare?
What do you mean by discrete events?
Rather than the span a certain time takes, just logging, hey, this event happened, when you're not so concerned with what the timing is, but more of what features are being used. You showed that a little bit with the the flow. But I was just wondering if there's something different, or you just use spans for everything and it's fine.
So yeah, the three most popular or most requested features that we get are around three areas. One of them is performance, one is errors, and the last one is usage. And this is kind of it opens up very interesting questions that we can now think about how to answer. So for example, this code gets run a lot in production. It has a lot of issues. It's there's a lot of interesting things there to explore, and yet nobody's actually using it in tests. So in the test environments. So that by itself, just from a coverage perspective, is very interesting. At the same time, we saw that with that dead piece of code or code that doesn't get executed at all. And that's also very interesting. It's sometimes very interesting for me as a product manager as well to kind of take a look and see, okay, these areas in the code, they're only used in this one flow, and what is this flow that's using them, and which API and which customer and so on. So definitely usage. And I kind of think about it sometimes like Google Analytics, only kind of applied to code, where you really want to understand kind of how that code gets used.
Thank you.
We have another question from Hamilton. Can you spend more time discussing the analysis tools for performing a post-mortem on when who do what to whom?
Yeah, so I think that post-mortem are kind of a very bad bias that developers and DevOps guys and SREs kind of developed over the years. And what I mean by that is that there was a natural predilection of the observability toolings to focus just on the postmortem. So how do we alert when things are wrong? If they're wrong, how do we track down like exactly what happened? And yes, distributed tracing is an amazing tool to do that, because you can find the error, you can look at the request, you can look at attributes that are saved across the spans to understand what data went through. And there's a lot that it can contribute there. The only problem is that it's way too late, right? It's if you got to the post-mortem, you missed a lot of the kind of warning signs that may have been there along the way. So I think we're going from a world where observability is utilized 100% in the monitoring leading to post-mortem world to a different reality where a lot of that data is being made available in the CI, in the testing, and in dev, where you can actually see, well, this query is getting slower and slower, and it's going to be an issue. And I don't need to wait for the post-mortem anymore. Does that answer the question?
Roni, I used the wrong word when I said post-mortem. The only reason I use that word is because it's already happened by the time that you've observed it. So yeah. I was really hoping to learn a little bit more so I can understand the instrumentation for the observability, but I'd like to understand how you mine the data to get the what was observed. How do I turn that into something useful that, for instance, could be used that, like you said, if you're noticing that a particular loop is slowing down, you could trigger an event to send an email that alerts somebody. I don't know. I just figured that there's probably something there that you could spend a little time that would kind of dig out more of the benefit, where we would say, "Oh, I've got to have some of that."
Yeah. So to maybe focus the question a bit more, are you talking about the ways to collect the data, which is
after you've collected it?
After
you mentioned the tool. I can't remember the name of it. Digma.
Yeah, Digma is the project that I was just showing. Yeah.
Right. So I was wondering if you could focus a little bit on sort of what I think of as the benefit out of this, which would be not just the collecting of the data, but turning it into meaningful reports or triggering events based on, I don't know enough about it yet, but I'm suspecting that if you were to talk about that a little bit, I would understand how to turn this into something actionable a little better, rather than just me looking at the data from the monitoring or from the tracing. Is to, I'm assuming that there are tools that you can use to assist with that. To, like you mentioned at the beginning, that you asked Bill, what value is he seeing out of it? And he said, well, to be honest, I'm not using it because I read out of what that response was, is that he didn't understand what he was looking at. So I'm
Yeah.
just trying to find out, how do you take the tracing and turn it into something that is human readable, if you will, or, you know.
Yeah, so understanding exactly what is the issue, understanding that there is a specific slowdown after this commit that I made or in this modified code. All of these things are kind of the heart of Digma, which is around data science, really. So these are things.
Maybe what I'm asking, Roni, is if you can spend a few minutes more going through some of the Digma and how it integrates and how you generate output using Digma. I mean, how do you process the output using Digma so that it becomes what's the word I'm trying to think of here? That the data becomes more valuable because it has been processed. So if you can discuss the Digma aspect of it a little bit, maybe.
Yeah, so you can think about the fact that if I don't have Digma at all, and I'm just using or equivalent, right? And I'm just using the out-of-the-box tooling that allow me to visualize my logs and traces and all of that. Coming to a conclusion that requires aggregation, like, yeah, it's nice that this thing and this thing and this things as discrete events happen, but I want to group them by the specific flow that they represent out of the hundreds of thousands of events that I recorded. Then I want to look at specific features of those flows, like, well, this specific area or this specific span is taking a lot of time and actually growing, and then coming to more complex conclusions, like whenever there is high degrees of concurrency, this specific area actually scales more and more badly. So it's I can kind of, if you can imagine Digma kind of analyzing this relationship between duration on the one hand and performance on the other, and you can kind of see this graph going like this, and then suddenly there is a big elbow in the graph because, you know, there's a lock in the database or something wrong happened. This is exactly the sort of things that for Bill would be impossible to do, because, well, it would not be impossible. It would just require effort, time, expertise, and attention. And what we're saying and what I'm saying is that if we rely on people's time, expertise, and attention, it will not happen, which is what we try to automate with Digma as a project. Does that make sense?
It does, and what I was hoping for is that you could discuss the Digma part of it in a way that the light bulbs go off of. How I can imagine instrumenting software so that you can get the data, but can you dive a little deeper in showing how you would capture that data and, as you called it, aggregate it so that you could observe trends over time, as an example?
Yeah, so that's like collecting the data is easy, not easy, but it's just a solved problem because OTel takes care of that. OpenTelemetry has a standard not just for accumulating data, but it has a component called a collector, which is basically a router for observability. You can send stuff to it and you can tell it where to send it off to. So if you want to keep your logs in logs.io or CoreLogix or Elastic, or if you want to save your traces somewhere, you can kind of specify how to do it. And Digma just happens to be a receiver for OpenTelemetry. So you can just say, well, as a part of my configuration, I'm sending my traces to Grafana, to Datadog, and to Digma. And what Digma does, as opposed to the other tools, is it doesn't save that data. It doesn't try to become this repository where I could always save individual discrete events. It aggregates them. How does it do that exactly? I can get into the weeds, but it will probably be a very technical discussion about both machine learning methods and statistical methods that we use both. But the idea is that we do something that when it's at its most simple, it's maybe akin to what a very, very good performance engineer would know to do with the data if he had time with it. And at its best, it goes more to the realm of machine learning, where if you did implement that and you would be able to do predictive modeling and clustering and anomaly detection and all of that, you would be able to implement that as well. But the flow of things is that the data just kind of like we have a CI/CD pipeline that takes code into production. In this case, it's a similar pipeline. It's a continuous feedback pipeline, and it gets observability from production and brings it back into the code. And this is how it's implemented. I'm not sure how to answer in more specificity without kind of going into implementation details and how we can collect, I don't know, 100,000 traces and cluster them using.
Yeah, I wasn't looking for the how is it implemented as how would you, as a user, how would somebody set it up to crunch through the data? That kind of thing.
That's the simplest thing in the world. It's basically you start Digma, which is right now, it's going to be SaaS and very easy to consume that way. But right now it's just something, a Docker Compose or Helm file that you run on your system. This will be the receiver. From the OpenTelemetry side, you just run your Python code with another runtime, like another CLI that bootstraps OpenTelemetry into it. In the parameters that you provide, you specify where to send it to, and this could include a tool like Digma, for example, and that's it. You've just connected the dots. You have information going into Digma, and you have Digma processing it to create the insights and analytics. Make sense?
Okay, so what I'm hearing from that basically is there are not a lot of knobs to turn in Digma. You just turn it loose on the data. You don't configure it to.
Yeah.
Okay, very good. Thank you.
Happy to help. And any other questions from the audience?
I had a related question to that. And are there tools maybe besides Digma, maybe including Digma, that take these logs and do a semantic trace in terms of, per some observed output, what contributors most likely led to that, so that effectively, rather than having to dig through the logs and have or to have Digma to indicate what portions of the code need to be cleaned up, if I were to specify, here's a type of output I care about from these run logs, and given my code, what most likely contributed to that in a differential sense in terms of priority contributors, I guess the naive question is, are there AI capabilities that could consume the logs that OpenTelemetry would produce and facilitate an expedited trace down in terms of, you care about X was caused by A, B, and C?
Yeah. Unfortunately, not a lot, but I can. The good news is that everybody is working on these type of implementations. So there are capabilities in most tools that try to do similar things. I can't say they're very good, especially from a developer perspective. I think some of them are really good from a service level perspective. So if you have several business services and you want to kind of trace down a problem and maybe sometimes kind of do root cause analysis for that, I think there are some great options in all of the APMs. But in terms of taking it kind of a step like back and kind of looking at it before there is a problem and kind of understanding these types of dynamics, I don't think we've hit that point where AI is yet being used effectively there, but this is changing. So I'm guessing if we have this, if I'm invited to talk about a similar topic in this meetup a year from now, I'll probably have more examples.
Thank you. And I had a separate question as far as extensibility for OpenTelemetry. I work with hardware accelerators, GPUs, FPGAs. Many of
Yeah.
those have proprietary tracers.
Mhm.
Are there plugins for OpenTelemetry to use those device-specific tracer tools and augment the logs accordingly?
I think I'm not sure. There are a lot of different implementations of OTel for cross languages and libraries. I think the sweet spot for now is still kind of back-end languages, SaaS platforms. I haven't seen it implemented a lot in the embedded world. And, you know, very intensive GPU platforms. I haven't seen, I think they use more profiling than tracing and work a little differently. But if you send me like specific platforms or technologies, I can check.
Thank you. Thank you.
Perfect. Well, thanks everyone. I really enjoyed the chance to talk about this, and I hope they kind of managed to get across some of the vision, at least that I had when I got started. I have to confess that I knew nothing of OTel, let alone observability a few years ago. But it was a rabbit hole that was very interesting to explore, especially since I've seen it directly impact team performance and release quality, and that's why I think it's so important. So thanks.
Thank you so much for speaking to us, Roni. That was a great presentation, very interesting. We would love to have you back. Thank you so much.
Thank you guys. Bye-bye.